supposed to be to the third?
Yes. Okay, so let's rewrite number 1 so it says to the third, because that's a typo. Okay, so it says to use a linear approximation. So in my head, I'm just going to think, find the tangent line. Okay, this is something to the third power. 3.01 is very close to what number to the third? 3. So there's a couple different ways you could set this up. If you notice on this one, they didn't tell you what function they wanted you to use, which means you can come up with your own function, okay? So we've got 2 options. We could, well, more than 2, but I'm going to go with 2. We could say f of x is x to the third, and the a value that we're using is 3, because 3 is very close to 3.01, right? So 3 to the third. Or I could say f of x is x plus 3 to the third, and then my a value is 0, because 0 plus 3 is still 3 to the third, which is very close to 3.01 to the third, okay? So you can set it up multiple different ways. You will get the same answer as somebody else who did it differently than you, okay? So first way, second way. First way, okay. So we're going to go ahead and we're going to find the tangent line, and we're going to find the tangent line at 3. That's going to be like our x value of our point of tangency. Okay? All right. So if we do this, what should I do first to find the tangent line? Derivative. So f prime of x is 3x squared. And then what do I do? Plug in 3. F prime of 3 is 3 times 3 squared, 27. Okay. So we have the x coordinate, we have the slope. What do we need? We need the y coordinate. Okay, so I'm going to go back up here, and I'm going to erase. Are you guys okay with me erasing the second option? Since we rejected it. Rejected. Okay, so there's our function. Now I'm going to go ahead and say, okay, f of 3 equals 3 to the third, which is 27. So we have the point 327. And we have a slope of 27. And we're going to use that to write the tangent line approximation, also known as linear approximation, also known as like derivative approximation, all the approximations. Okay, so I'm going to say L of x equals. And then those notes would be real helpful right now.
Oh, it's going to be 27x minus 3 plus f of a to plus 27.
So if you guys can see, this is just the equation of a line, right? But instead of having y minus 27, they're using L of x, and then they already moved the 27 over. Does that make sense? So it's exactly like what we've been doing. They just changed it slightly and called it something different, like we often do in calculus. Because then it's isolated. And this,
that it's actually the thing.
Right, and this notation, L of x, communicates to the person looking at your paper, this is not really the function, and this is only going to work for numbers close to this, but not all the numbers. Okay, so what do we need to plug in for x so that we can approximate 3.01? What would we have to plug into that? Wait, what would we have to plug into the original? 3.01, right? Okay. This one would have been a little, oh, I erased it. Did you see me go to it and then it was gone? This one, whoa, what? All right, the other one, let me write this again. F of x equals x plus 3 to the third. If we had done this version of the approximation, what would we have had to plug in? Just a 0.01. Yeah, just a 0.01. So when you're trying to figure out what you need to plug in to the linear approximation, it's whatever you'd have to plug into the original function to make that number happen. So this version, you would have had to plug in 0.01. Yeah. Yeah. Well, not A exactly.
Oh, right.
Yeah.
Yeah. What you're representing.
Yes. Yes.
Sorry, that's what I meant.
For 2, could we make the linear approximation based off of a being 16 so that our numbers are round, and then plug in 17 at the end?
Mm-hmm.
So the equation can be based off the different numbers, at least, as long as it's within.
Well, this one is as well. It's based off 3.
Okay.
In fact, they'll always be like that. They'll always be based off of a different number. So if we did this version, it was based off of 0, right? You would have plugged 0 in, right? 0 plus 3, 3 to the third is close to 3.01 to the third. But we did this one, and so if we look at this and say, what do I need to plug into this original function to get to what I want? It would be 3.01. Yeah, so I'm going to go ahead and plug this in. I get 27 times 3.01 minus 3 plus 27. What is 3.01 minus 3? Just 0.01. Okay. This is, if you don't have a calculator, it's a little bit easier as fractions. I'm sorry. So 0.01 written as a fraction would be what? 1/100th, right? We've got the 10th place, the 100th place. Okay, so I have 27 times 1/100th plus 27. So I've got 27 100ths, right? Plus 27, which you're right is 27.27, because 27 100ths. So we're going to say that 3.01 to the third is approximately 27.27.
How far of an approximation will they take?
I would say they don't ask the question like that. They don't say, like, can you take this approximation? They just tell you to do it. I don't know.
If I wrote 30, clearly that would be wrong even with the approximation.
Well, it wouldn't be wrong. It would just be further off.
That's what I'm saying.
Yeah.
How far will they accept?
Yeah.
We're like, okay,
but that's not even a question they would ask. That's what I'm saying. They would give you a problem, and then you would just get as close to it as you could. And it would be, yes, and it would be, they do FRQs with approximations, but they are in BC in a different context, and it's obvious how you should do it. Like, it's consistent, yeah. All right, so let's try number 2. Let's get it set up.
So you lied.
What?
You said that it would be all approximations, but it's not.
What do you mean?
There are approximations that are different going forward from this. Aren't there? You said in BC there's a different context in which it's used.
But it's not used like this. It doesn't use linear approximations. I don't know what I lied about.
We've already been doing approximation when we can't get an exact number.
Yeah, we've been doing lots of approximations.
In math all the time.
Yeah.
When you don't have a calculator. Even when you have a calculator.
Yeah, when did I lie?
Rounding is approximation.
That what is?
You said that this was only approximation.
Steven, shut up. Thanks.
All right, so the function f of x, what function do you guys think we're using? Yeah, so we could, so square root x, right? So if we use f of x as square root of x, then what's your a value going to be? 16. All right, what if I wanted to do like f of x is square root of 2 plus x? Then what would your x have to be? Yeah. You can still do it.
Why?
Because you can.
Better yourself.
Yeah. Which one do you guys want to do? No, let's do the second one. All right. So, yep, we're going to do the second one because you're going to do that like the first one on number 4. You're going to use just square root x there. So let's do the second one. It's more fun. Okay. So start here. We're going to use this one. So we'll say first I'm going to go ahead and plug in 14. What's the purpose of that? What was the purpose of what I just did? I'm getting the y-coordinate for the point. Yeah, Desi said that, but the words in my head, they were English, but they didn't translate as math. They were just English in my head, and I didn't know what they meant. So plug in, it's because I was thinking about what she said. So. All right, plug in 14, and what do you get as a result? 4. You just get 4, all right? And then we have to go ahead and we have to take the derivative.
Why isn't it negative?
Because it says positive square root. It doesn't say plus minus.
You're not making this work.
All right, so f prime of x is 1/2
So 1 over 2 root x.
2 plus x.
Oh, wait, no.
Negative 1/2 times 1. Okay. So we have 1 over 2, right? There's my 1/2. And then what else do I have on the bottom? Okay, so now I have to find f prime of 14. So I've got 1 over 2 times the square root of 2 plus 14, 1 over 8. Okay, so my linear approximation is, or my equation that will give me my linear approximation is what?
X minus 14 plus 4.
Okay. So now I have to go back up to this original function, and I have to say, what would I plug in to get 17? Because that's what I want. I'd have to plug in 15. So see how we do that? We can start off with any function we want. We just have to make sure at the end we plug in the correct number. Okay? So if we were doing this very weird one that none of us ever would have done without me making you, then we would have to plug in 15. So I'm going to say L of 15 equals 1/8 times 15 minus 14 plus 4. Okay, so I have 1/8 plus 4. So we're going to say that the square root of 17 is approximately 33/8. Yeah, it's kind of cool when you don't have a calculator. It's like, You do not, because you are not the one who took the square root. The square root was already there and it was listed as positive. Yeah. The reason was I was showing you guys could do it all sorts of different ways, that you've got options. Okay.
Could we add another square root nested inside the square root if we really felt
You
like
could make this as crazy and complicated as you want, but please don't do that. Oh my gosh, you're going to do that on a test on an F or Q and I'm going to have to like grade it. It's terrible.
Do it.
I'm going to be like, let me put away my answer key and think about this.
When you do 1 plus 2 plus 3 plus 4 and 2.
I mean, you can be as ridiculous as you want when it comes down to it.
I need to do square root of a factorial.
Please, no.
2x.
No. All right. Are we good? Are we good? We can do the things? Yes? I don't know about square roots, but it's how they approximate e to the x and all that stuff. Yes, it's very interesting. It's very interesting, yeah. All right. So, if you look at the questions, you're listening. So after this, there's a few questions where they tell you how you have to do it. So in the first 4, you are able to choose the function that you work with, but later on they tell you you have to do it a certain way. Make sure that you follow the instructions on how you have to do it, because it's going to force you to think in a way that's a little bit less comfortable than maybe what your default would have been. Like number 6 is pretty comfortable with the default. Number 8, a little bit less comfortable, because instead of doing just square root of x, they're doing square root of 16 plus x. That's going to make you think a little bit more. When you get to number 10, I probably would have wanted to do just cube root of x if that was me, but they're making you do cube root of x plus 4. So just pay attention to how they're forcing you to do it, because it's going to make you think in a way that's going to make these make more sense in the long run. It's going to make you think so that you're less comfortable with them, but ultimately so you understand them better. Okay, make sense? All right, go ahead and get started. The first 2 answer keys are in the back. I'm working on the other ones as we go. There will be a point later on in the period. Right now, I think you can only do 1 through 12. We'll see how far we go. The problems aren't all... there's so much space there you'd think they're super involved, but they're not necessarily super involved. I just gave you lots of space.
Give us footnotes.
Yeah, I put footnotes in though. Aren't they fun?
Again, exclamation, question mark. Yeah, remember, displacement is distance from the beginning. Total distance. All distances traveled back and forth.
So for 5, we're just like writing it out.
Yep.
All right.
Yep.